everybody. Just a quick screencast talking about how to decode science word problems. The word problems that we're going to run into in physics most often are going to be formula-based. In chemistry, it's a mixture of formula-based and dimensional analysis problems. Generally speaking, though, the tools and skills that you need to solve these problems are going to be the same. This video will focus specifically on formula-based problem solving, but the steps that we go through are going to be very similar. And so the first step that we need when we look at a word problem is we need to note numbers. When reading a problem, locate those numbers that have units after them first. I suggest boxing them or circling them within the problem itself. These values are going to be clues that help us set up our solution. Underneath the problem, I like to tabulate or put an organizational table that includes these numbers and their units. Organization's really important when working on word problems, and I find that a table really helps me keep track of what's going on in that problem. So I have a problem here that we're going to be using. A sprinter runs down the track at 10 meters per second. How long will it take the sprinter to cover the 400 meters? Well, as you can see, we have two numbers. We have 10 meters per second here, and then we have 400 meters here. Both of those have a unit afterwards, which is going to be important for us when we solve our problem. So underneath my problem, I'm going to set up a small table that includes both of these numbers and their units. Do not forget the units. And my next step is to use those units. The unit that's attached to the number indicates what type of measurement this number represents. Our formulas that we'll be using are going to have variables, and these variables are equal to a particular measurement. So knowing what those units mean is going to be really important and helps us identify formula variables. So for example, we use a lowercase v for velocity in physics and a lowercase d for distance. All right, if we were in chemistry, maybe we would have a volume measurement and we would have a capital V, or we would have a time measurement, and we would use a lowercase t. All right, once we know what each number represents, you want to put the symbol that represents that measurement with the number in your table underneath the problem. Another thing to keep in mind are units matching. If we have two distant measurements within a problem, both need to be in the same unit. So for example, if you have one measurement that's in meters and another measurement that's in kilometers, we need to choose one or the other to match. All right, we need to do this before we plug into any formulas. So here's our problem again. We've got our numbers with units circled already. But our table, you can see I've now put the variable symbol, and I've told you what each one means next to the number that it accompanies. All right, so now we've got our units set up. We know what those units mean. The next step is to figure out what the problem is asking for, the point of the problem. All right, it's usually spelled out near the end of the problem, but can be anywhere within that problem. So make sure you read the problems very carefully. All right, I always look for key terms such as how, what, where. All right. And I like to underline these words and the words that follow. So is there a descriptor that follows my how or what? Like, for example, how fast, how far, what is the acceleration, how much time, what was the speed? These are some examples of what the problem is looking for. We use these descriptors to determine what variable we're trying to solve for. How fast? That must be velocity or speed. How far? Distance measurement. How much time? Time. Write your unknown variable at the bottom of your list with the known variables, along with the units that you would expect for that problem. So we're back to our problem, and our table, our how long is our question, what the problem is looking for, which tells me that I'm trying to solve for time for this particular problem. All right, so I now know what I've been given, velocity and distance, and I know what the problem is asking me for, time. Now I need to take that information and find a formula. Right? Once you've identified your knowns and your unknowns, you want to look at your formula list, or if you don't have a list, use what you know, right? And find a formula that includes all of the information, right? You need to be careful here. Do not force the formula. I have a lot of students who try to just pick a formula that looks like it'll work, but they're missing information, all right? In addition, maybe you have extra information that you don't actually need. All right. If you have a formula that's going to solve for your unknown but does not need everything that's been given, okay, you have the right formula as long as you have the information you need to solve for that unknown. All right. So here are some examples of some formulas that we use in physics. All right. If we look at our table, we're looking for a formula that contains velocity, distance, and time. So if I look at my formulas over here, there's really only one option. My V equals D over T. So that would be the correct formula to select for this particular problem. It contains both of my knowns and my unknown variable. Now that I've selected a formula, it's time for the actual mathematics, the plug and chug portion, as I like to call it. All right, we need to plug our known variables into the formula where they belong based on their symbols and making sure that we include our units. And now it's all about the algebra. All right, we may need to rearrange the formula to solve for our unknown. When that happens, remember that adding and subtracting are opposites and multiplication and division are opposites, and that what you do to one side of the formula, you must also do to the other. All right, so we pull up our problem again. Here's our table. Our formula that we selected was our velocity equals distance over time. Now for this problem, when I plug it in, I put velocity in for the V, I put 400 meters in for the D, and I have my time variable underneath here. So I need to isolate time. To do that, I'm going to multiply it to both sides, which will let me cancel it from underneath the 400 meters. Once that happens, I need to divide both sides by the velocity, the 10 meters per second. Once I do that rearrangement, I can solve for t, and I get 40 seconds. The last and one of the most important steps in problem solving is analyze your answer. All right, before you move on to the next problem, make sure you look at your answer and ask yourself, does that make sense? You will get a lot of math errors with just that simple. So, for example, if you're trying to determine the distance that an airplane flies from Boston to Los Angeles, you do all your work and your calculation tells you it's 1.25 meters, you should ask yourself, does that make sense? Does it make sense that the distance from Boston, Massachusetts to Los Angeles, California is 1.25 meters? Hopefully, your brain will say no. Right? That means you must have a math error somewhere. So you need to go back, check your work, fix it, and then ask yourself that question again. All right, for our problem, we got an answer of 40 seconds. All right, so if we look, we're moving 10 meters every second, and we're going to cover a distance of 400 meters. So 40 seconds is a reasonable answer. All right, now if you'd gotten 4,000 seconds or 0.004 seconds, then you might have said, okay, maybe I need to go back and check your math. All right, but in this case, the answer seems reasonable, so you're pretty good to go. You're also always welcome to take your answer and plug it back into the formula with your other two variables and see if the two sides of your formula equal each other. If they do, then you know that your answer is correct. All right, well, that was just a little intro. I hope that that helps. If you have any questions, do not hesitate to reach out and ask. I'm always available and happy to help.